My first one I said no because x is -3 twice with different y values. Okay? My domain is -9, -8, -3, and 6. My range is -6, -4, -3, 2, and 7. My next one is yes, it is a function. My domain is 1/2, 2, 3, 8, 9. My range is 1/2, 2, 3, 7. How'd we do? Thumbs, good? Bad?
I just wrote it on the wrong. Like I wrote the domain order.
So make sure you're putting the right one in the right spot. Okay, domain is X, range is Y. Domain is X, range is Y. Okay? So the good thing is, next one, almost identical, same exact process. What do we look for to determine if a table is a function? Can't have repeated x's. How are we going to write our domain and range? Same. List x values, small to big, no repeats. And then our range is we're going to list the y values, small to big, no repeats. Why am I doing these as I would a discrete graph? Because these are the only values I have. I don't know if I have a continuous graph that exists everywhere. So I'm assuming it is discrete. These are the only values I know that my relation exists at. Okay? So unless it's a word problem, which we're going to get to word problems in a little bit, if I am ever given ordered pairs, a table, or the third one we're doing today, I'm always assuming it is discrete, which means you list it out, small to big, no repeats, unless it is a word problem. Okay? So, looking in my X column, guys, do I have any repeat X's?
Yes.
Yes. Do they have different Y values? Yes, making them different points. Is that allowed? No. So is this a function? No. X equals 7 twice. That's not allowed. Okay, so my domain. Domain is all your X's. Notice these are already in order from small to big. We like that. Okay. The only difference is when we write our domain out, we're not going to repeat the values. So it's -2, -1, 7, 9. I don't write 7 twice. Now, my Y values, are my Y values in order of small to big? No, because when you're making a table, the X's are in order, but the Y's have to be paired up with the appropriate X value. Okay, so sometimes they might be in order for us, but sometimes they won't. So what's my smallest what's my smallest Y or range value? -2, then -1, then 3, then 7, then good? Next one, look at your X's. Do any of these X values repeat?
No.
No, -9 and +9 are different numbers. So is this a function?
Yes.
Yes, because none of them repeat. So my domain is all the X's. What's the smallest? Then -9, then -6, then -4, then +9. And then my range is my Y values. What's my smallest Y value? 16, then 36, then 81. Am I going to write 81 twice?
No.
No, then 100. Good? Do you see how this is exactly the same thing? It's just given to me in a different format. Okay, but if we have ordered pairs, can't we make ordered pairs into a table?
Yeah.
Yeah. Okay. Let's do the next one. Look at your X's. Do any of my X's repeat?
Yes.
Look at your x column.
Yes.
Yes, x is 4 twice. Do they have different y values?
Yes.
Making them different points. So is this a function? Are you allowed to have repeat x's? No. X is 4 twice. That's not allowed. You're not allowed to have repeat x's. You're not allowed to have repeat x's. Remember, domain is x, so I'm going to list out my x's. 1, 2, 3, 4. Then I'm going to list out my y's for my range. 1, 2, 3, 4, 5. Are we thinking this is pretty easy so far today? You're just listing out the values, small to big, no repeat. Okay? If you have repeat x's, you're not a function. If you don't have repeat x's, you are a function. Okay, last one. Is this a function? Do you have repeat x's, guys? Yes. Do they have different y values? Making them not the same point. Okay, you can't have repeat x's that have different y values because then that means you don't have the same point. So no, because x equals 0 and x equals 6 twice. I have repeat 6's. Oh, but do I really have repeat 6's, guys? No. Nope. So just x equals 0 twice. Because these are exactly the same points, right? Okay, so let's list out our domain. 0, 6, 8. I don't need to put the 0 again, don't need to put the 6 again. Because small to big, no repeat. Then let's do our y values. Negative 8, negative 6, negative 4. I don't need to put negative 6 again. And 0. Good? Next one, still the same, guys. How do we determine, well, I guess this one's slightly different. How do we determine if a mapping diagram is a function? You can't what's going on? Okay. Thank you. You can't have more than one line from an x value. So when we do our mapping diagrams, the correct way to do it is small to big, no repeat. So you can't look for repeats if we're saying you don't repeat a value, okay? But you're going to have lines connecting your x values to the y values. If you have multiple lines from an x value going to different y values, that's how you know you have repeated x's. But we still do our domain and range the same as we've been doing today. You list the x values, small to big, with no repeats. And you do the range the same. You list the y values, small to big, no repeat. Okay, on your mapping diagrams, there's a little bubble, those are your x's. The second bubble, those are your y's. Okay, the first bubble is your x's, the second bubble is your y's. When x is 3, how many y values does it go to? Is that allowed? No, that would mean I have one ordered pair 3, 4 and one ordered pair 3, 9. That means you have repeated x values. Okay, so no, this is not a function because x equals 3 twice. So do y'all understand whenever I put you can't have more than one line from an x value? My x value is 3 and I have 2 lines, meaning it has 2 different y values. That's not allowed. Okay? Domain is x, so we're going to list out our x values, small to big, 3, 4, 6, 8, 9. 3, 4, 6, 8, 9. Then we're going to list out our range or our y values. 3, 4, 6, 7, 9. They're already in order. We like this. Because when you are doing your mapping diagram, you're supposed to go small to big, no repeats. Small on top, big on bottom. Okay? And you don't have repeated values. Next one. Is this a function? Do any of these x values, x, y, do any of these x values have more than one line from them? No. So is it a function? Yes. So let's write out our domain. 0, 5, 6, 8. And then range. Okay, this is tricky, guys. Don't just list out all the values. Is there a line that goes to this 2?
No.
No, you don't have a y value of 2. Is there a line that goes to this 6?
No.
No, so you don't have a y value of 6. Do you have a line going to the 0? Yeah, do you have a line going to the 3?
Yeah.
Do you have a line going to the 7?
Yeah.
Yeah. Okay, so we're only listing out the values that we have lines going to. They tried to trick you. How cruel. Next one, are there multiple lines from any of these x values?
No.
No, so is this a function?
Yeah.
Yes. Your domain is your x bubbles. 1, 3, 6, 8. Already in order of small to big and no repeated values. Then your range is your y. Let's cross out the y values we don't need. Which y values do I not need in my bubble? 1 and 8. There's no line going to 1, no line going to 8. So what are my only y or range values? 0 and 5. Very good. Okay. Y'all do the next one on your own. Okay, is this a function, guys? Yes. Your domain, there are no numbers that have 2 lines from it, no x values that have 2 lines from it. I don't need 1. So 6, 7, 8. How are we doing on that? Pretty good? Do we feel comfortable with these? Okay, now we are going on to doing our word problems. We're kind of putting all of this together, okay? Who wants to read for me? Somebody? Anybody? James, read for me, please. Alexander, sorry, I was looking at your middle name. Alexander, read for me, please. Sorry.
Tickets to see the new Spider-Man movie cost $11 per person there, and you invited 4 people to join you. You're going to be there no matter what. These are representations below of possible values for the number of tickets that can be purchased and total amount of money that can be spent on tickets.
Very good. So, we need to first determine if this is discrete or continuous. Because if it's discrete, our graph is just going to be dots. If it's continuous, then it's going to be connected. If it's discrete, we're going to have just a list of x values and y values for our domain and range. And if it's continuous, we're going to have an inequality for our domain and range. Okay? So we have to first start. Does this represent a discrete or a continuous situation? The way you determine is continuous, that means it can exist at every value. Okay? If it's discrete, it just happens at distinct values. Okay? So what two things are we comparing here? What two things are we talking about? So the total cost, the number of people. Can you invite 1.25 people to go to the movies with you? No. When you're buying tickets for a movie, they only exist at whole numbers. Okay? So this does not exist at decimals. Okay? Only whole numbers. So would this be discrete where it only exists at certain points, or continuous where it exists everywhere between a starting and a stopping value? So continuous means it happens at like decimals. Discrete means it's only happening at certain exact values. So discrete because you only can have one person. Then you jump to 2 people. Then you jump to 3 people. You can't have like 2.3 people come into the movies with you. Okay? So this is an example of discrete. And the reason for that is you only have whole number people. Okay, next we're going to write our equation because you need your equation to be able to do your mean and range. Okay, it says it costs $11 per person. So 11, what is per mean in math? But add, subtract, multiply, divide equals. Multiply per person. So 11 times x, so 11x. So our equation is going to be the cost equals $11 times the number of people that come. So y equals 11x. Okay, domain is x, which is my people. Okay, because you first have to know the people to then know how much it costs to go to the movies. Okay, so since it's discrete, are we going to write a list or an inequality? A list, so do your curly bracket. Okay, your set symbol. Okay, so people, it says you've invited 4 people to join you. Does that mean all 4 people are going to go? No. What if none of your friends are available to go with you? How many people would be going to the movie? Just one, you. What would be another possibility? 2 people, you and 1 friend. What's another possibility? You and 2 friends, 3 people, then 4, then 5, then are we gonna ever have 6 people going? No, because you only invited 4 people, so you and 4 people would give 5 total people. Okay? So there's your domain. In order to do the range, guys, you have to have your equation and the domain. You're going to put the equation and the domain together to then get the range. We know it's going to be a list because it's discrete. What we're going to do is we're going to substitute in each of these x values into our equation. So if 1 person goes, what's the cost of the tickets? $11. If 2 people go, if 3 people go, if 4 people go, and if 5 people go. Are we okay with how I got my range? And range is total cost. Your total cost depends on how many people you have coming to the movie theater. Okay? So let's graph this. When we're graphing, you want to label your axes. Domain, which is x, is your people. So I'm going to put number of people. And I'm going to kind of skip a space every time. So I'm going to do 1 person, 2 people, 3 people, 4 people, 5 people. Could you do your 1, 2, 3, 4, 5 just right next to each other? Yeah, but I want it to be a little spread out. This is personal preference. As long as you label it consistently, there's more than one correct way to do this. Okay? So I labeled my x-axis, number of people. We have 1, 2, 3, 4, 5 people going. Okay? I'm going to label my y-axis total cost. And I'm going to label every other one. What do you think I should count by? 11, because my cost is jumping by 11 each time. So 11, 22, 33, 44, 55. Again, I'm jumping a space each time just because I want more room. Are we okay with how I labeled my graph? You need to have your x-axis labeled and your y-axis labeled with words, meaning what they represent, and then you need to have them like dash marked out by what you're counting by. Okay? So now we are going to put our points. If I have one person going, it's how much? So one person, $11. Two people is 3 people, 4 people, and 5 people. Do I connect those dots, guys? Those make a really nice line. Should I connect them?
No, because it's a discrete graph.
It's discrete, so you don't connect. So let's write don't connect because it is discrete. If I were to connect it, guys, I would say that there is a cost that's associated with 1.5 people going. Well, there's not a cost associated with 1.5 people going because you can't have 1.5 people go to the movies. Okay? So it just exists at those distinct values. Okay? So now we're going to do our mapping diagram. Remember, the first little bubble is your x's or your domain values. So I'm going to go 1, 2, 3, 4, 5. And then the second bubble is my y values. 11, 22, 33, 44, and 55. And I am connecting them. When one person goes, the cost is $11. When 2 people goes, it's $22. When 3 people go, it's $33. 4 is $44. 5 is $55. Are we okay with how to make our mapping diagram? Okay. Then we're going to make a table. One person is $11. 2 people is $22. 3 people is $33. 4 people is $44. And 5 people is $55. Okay, then we're going to write our ordered pairs. 111, 222, 333, 444, and 555. Good? So this is multiple different ways to represent this situation, okay? We good? We're going to do one more today, guys, and then we're done. One more, then we get to do our homework, okay? Heidi, read this one for me, please, sweetie. Great job. Okay, so is this discrete or continuous? So before you say anything, what are we comparing? What 2 things are changing? Volume and what? And what? The rate. The rate's not changing. The rate's always 500. The gallons, that's your weight, or what do we say, volume.
The number of hours.
The number of hours, okay, so time and volume. Can you have 1.5 hours?
Yes.
Yeah, can you have 1.25 hours?
Yes.
Yes, can you have 1.5 gallons?
Yes.
Yes, so does this exist at decimals?
Yes.
Yes, so would this be discrete where it only is existing at certain points, or continuous where it happens everywhere, or exists everywhere? And then think, anytime, almost anytime, I won't say anytime, almost anytime that time is one of your variables, it's going to be continuous, because time is continually going. Okay, so almost always if time is a variable, it's going to be continuous, because time is continually going. There's no jump in time. You don't go from it being 1 o'clock in the afternoon to magically now it's 2 o'clock in the afternoon. There's time that exists in between those two. Okay, so this is continuous. And let's put time is almost always continuous. Okay, so now we need to write our equation. Our equation is y equals. How much water is starting in the pool? So that's your starting point, 1,500. Are we adding or removing water? It's being drained, which means I'm going to subtract. How much water is being removed? 500 gallons per. We see that per again. What's per mean? Multiply per hour. So 500x. Okay. So, when we have a continuous function or a continuous graph, do we list out our domain and range or inequality it? Inequality. So what's the smallest number of time that the pool's going to drain for? Smallest number of time? 0. I'm not draining my pool right now. I don't have a pool, I wish I did. But the pool's not being drained right now. 0 hours. Less than or equal to x, less than or equal to. Now I need to figure out what's the most time my pool's going to drain for. How long is it going to take for the pool to be empty?
9 hours.
How'd you figure that out? 500 times 9 is 4,500. So 4,500 minus 4,500 is, he solved it. So he just thought, okay, how many hours is it going to take for the amount of water I have in the pool to be equal to the amount of water being drained? Because then it would be 0. So you could do 0. I want to see when is the water going to be 0. 0 equals 4,500 minus 500x. I'm going to move my 500x to the other side. So I'm going to add it. So then I get 500x equals 4,500. And then divide by 500. And I get x is 9. So at 9 hours, my pool will be drained. It will have 0 water in it. Okay? Now, Dylan just did that in his head, which is fine as well. Okay? Good with that? Okay, so now my range. What's the smallest number of water that's going to be in the pool? 0, when it's all the way drained. Less than or equal to y, less than or equal to. What's the most amount of water that's going to be in the pool? 4,500. That's how much you're starting with. Okay. So my x is going to be labeled hours. I'm going to count by ones because I have to get up to 9. Okay, I'm going to count by ones, but I'm only going to label every 2 because that could get messy. So every hash mark is meaning 1 hour, but I'm labeling every 2 hours. And then my y-axis is going to be gallons. And each dash mark is going to be 500, but I'm going to label every other one, so I'm labeling every 1,000. So it's 1,000, 2,000, 3,000, 4,000, 5,000. Again, I'm labeling or numbering every other one. Okay, so let's think. If it's going to be continuous, are these points going to be connected? Yes. Okay, so I really only need my starting point and stopping point. Okay, because it's not going to go on forever. We're going to start draining and then we're going to stop draining. At 0 hours, how much water's in the pool? 4,500, right? So 0, 4,500. How long did we say it's going to take to drain the pool?
9 hours.
So at 9 hours, how much water is in the pool? So at 9 hours, there's 0. So I'm going to connect those because this is continuous. Should I extend it past the starting and stopping point? No. Okay. We start draining, we have a lot of water in the pool. We stop draining, there's no water in the pool at 9 hours. Okay? Now, when you're doing your mapping diagram, it says you need at least 4 points. I only have my starting and stopping, so I need to get 2 more points. Okay, so tell me an x value, tell me a number of hours in between 0 and 9, not 0, not 9. Tell me a number of hours, you can pick any. 4, okay? So what's 4 times 500? 2,000. So what's 4,500 minus 2,000? 2,500. So at 4 hours, I have 2,500 gallons. Well, notice, is that point on my line? Yeah, it should be, right? Because this line is representing that equation. Tell me another number of hours. There's not a wrong answer. Between 0 and 9. Not 0, not 4, not 9. Because we've already used those. Tell me any number of hours. Ashna, tell me a number of hours. 8, okay. So what's 500 times 8? 4,000. What's 4,500 minus 4,000? 500. So at 8 hours, I have how much water in the pool? 500. So 8 hours, 500. Is that on my line? Is that on the line? My line isn't like 100% perfect, but is that close to the line? Yeah. Okay, so now we can do our mapping diagram. The x values we chose were 0 hours, 4 hours, 8 hours, and 9 hours. When we do our mapping diagram for our y values, you start with the smallest y value. What's the smallest? 0, then 500, then 2,500, then 4,500. Okay, so then we're going to draw our lines. At 0 hours, how much water is in the pool? So draw your arrow. At 4 hours. At 8 hours. And at 9 hours, there's 0 water. So notice how both my x and my y bubbles in my mapping diagram are small to big. Okay, now we're going to write our table. 0. When x is 0, what's y? 4,500. When x is 4, what's y? 2,500. When x is 8, what's y? And when x is 9, what's y? 0. Now we're going to write our ordered pairs. 0, 4,500. 4, 2,500. 8, 500. And 9, 0. We good? Okay, so we are done for notes for today.